And hello everyone, my name is Nurul Hanan and welcome to our presentation mini project video. For this week, we will show you guys the progress that we take to take the data using DAQ. So basically, each of us have to take the data to get the accurate data value. And also in this video we will explain you guys about how the LabVIEW works and also the coding. So I will pass this video to my friends.
Hi guys, today I'm going to show you how we take the DHT data from its digital input and transfer it into the analog input via ESP32. I will show you the codes and also how we're going to show how we're going to use it, our layout on LabVIEW to get the data itself. So first I'm going to talk about our Arduino code. Okay, first we have this code here to show it on blink, of course, and then we're going to take the data, the HT value right here. We're going to use it as temperature and humidity, and also we're going to change it using this two line of code, which is using the AC pin on our ESP. We only have two. We assign it into we're going to send it through pin 25 and pin 26 respectively. So the limits that or the constraint that we put is for temperature it's going to be 0 to 50 degrees Celsius, and for humidity it's going to be 0 to 100 and that's going to show, and that's going to send the data into the AQ itself using analog input. So here's how we're going to show it. I'm going to explain it a little bit. I'm going to go to new IV. Let's go. We're going to start new if it's possible. So here we're going to have our while loop. Just put it in here. Next we're going to need a DAQ assistance right there. Okay, in this DAQ assistance, it is very important step. For the input, we're going to select analog input and voltage, where the DHT going to use the ESP going to send analog input into the AQ. For it, I'm going to use this as an example. We are using a analog input 0 for DHT, I mean humidity, so we're going to put it right there. Alright, right here we're going to change the name right here, the name on the channel. Let's say we're going to use humidity right there, and the maximum and minimum value, because the ESP going to send it 3.3 and between 3.30 to 3.3, so we're going to change it right there. For the terminal configuration, we're going to use RSE, and also the acquisition mode will be continuous sample. Next we're going to see at our samples to read and also our rate. We have done a few experiments on this to make it less noisy. I'm going to use 5 for samples to read and also 5 on the rate, because if we're going to use higher rate, it is very unnecessary and it will introduce a few. I'm sorry, I'm just going to put this 5 is going to introduce more noise into our graph and also our data that we're going to get. So we're going to put that there. I'm sorry. I'm going to wait for this, and then we're going to make it bigger for it so that it's easier. So in our front panel, we're going to look for numeric. numeric indicator right here. Then we're going to change the name into humidity voltage. So on here we're going to see the raw data, which is the what we're going to get, the value from 0 to 3.3 volts. And then what we're going to do is change this data into the humidity in percentage. How we're going to do it, which is we're going to divide sorry, what's block I'm going to use I already going to use this block right here. So we're going to copy this and paste it here. Okay, we're going to use our divide and then take the terminal to here. So this from the DAQ we're going to get 3.3 volts, and then we're going to have constants. Constants. Sorry, delete this first. I'm going to delete this first. It's easier if you want to see on quick drop. Sorry, not this one. Function palettes into numeric, and then we have to find constant numeric right there. Okay, in here we're going to divide it with 3.3 and then connect this to here, and then this will get our it's going to divide the data from the ESP and divide it by 3.3, and then we're going to multiply it. So we're going to find multiplying here, add, subtract, multiply. Yes, let's go. Going to multiply it with 100. So we're going to copy this, paste it there, change the value into 100. Why 100 I will show you later, but for now just stay tuned. Alright, and also we're going to get our new numeric indicator. So in here, from this we're going to get our new humidity in percentage. So here we just put humidity right there, and we're going to connect our like that, and then on the front panel we can go for waveform graph, yeah, right there, and put it right there. Take this, make it a little bit nicer. Will be humidity graph. So in this we're going to show it our humidity. So we're going to just put it right there. So we are done with our humidity part. So next what we're going to do is go back in here, because we're going to start adding channel into our next data, which is temperature. At the same one, let's say we're going to use analog input 1, correct that. So we're going to change the name again, change it into temperature. The others will be the same because we already set it on humidity. We'll also copy it. So we're going to just click OK right there. So we're going to see that it still come out with only one line. So what we have to do, so we're going to find split signal right here. Okay, and then we're going to expand it into 2. Then we can delete this and connect it into the split signal. One is going to be the humidity. We can change the position to make room for our next part, and we can also copy this because it will be very simple and it will be pretty much the same, because you just have to change a few value, put it right there, change the name. So this is will be temperature, voltage, voltage. This will be temperature in degrees Celsius, and this will be temperature graph. So as we look at, as I told you earlier, our constraint for temperature is from 0 to 50. So here we cannot use 100 because on humidity the constraints are 0 to 100. That's why we put we will multiply this with 100. So here we're going to change it into only 50. So the limits of our DHT or our temperature is going to be 0 to only 50, where humidity will be 0 to 100. So here pretty much it's very simple, it's easy to understand. And for FSR also we can do the same thing. Properties, add channel voltage, we're going to use analog input 4, but others are going to be the same also. Okay, next. In this sorry, going to wait for this few moments. Okay, on the split signal we're going to expand it a little more. Oops, too much. Okay, just one more. We can also copy this again. It's very simple, very demure. Control C, control V. Okay, we're going to get it right there. So connect this here, boom, change this into FSR voltage, change this into this is the FSR value in Pascal, and if you want you can also have the FSR graph, but it will be a little bit inconsistent because the value from FSR we get it from 3.3, but the limits are going to be 4095. So on the graph will be a little bit noisy also, because from only 3.3 and we're going to multiply it with 4095. So as you the data will be a little bit inaccurate because it's from a very small numbers you're going to change it into very big numbers. What I can say, it's a little bit unreliable for this. So here's what we're going to use for our mini project. We got all of our data that we're going to use in the AQ, which is humidity, temperatures, and also FSR sensors in Pascal. So that's pretty much it. Next you're going to see our time lapse of the process of our we taking data. A few data that we're going to take, which is from Blink. We're going to have same data, temperatures, humidity voltage, humidity, temperature voltage, temperatures, FSR voltage, and FSR in Pascal. But also we're going to use it on we're going to have the same data on Blink and compare it to see if it's accurate or not. So enjoy the time lapse, and I'm going to sign off now. Thank you.
Hello, my name is Nasrim Fikri bin Fuad. So, as you guys already watched the previous part of our introduction, my friends telling about how we convert the AQ to LabVIEW, and then our time lapse on collecting data. So now, for my part, is I'm gonna conclude everything for this mini project video. So, for our mini project, collecting data with a DEQ instrument and integrating it with the LabVIEW is very important because it provides highly accuracy, real-time measurement and monitoring of physical interaction, which is our fit for this our mini project. And also LabVIEW will offer a simple interface for display, analysis and control, and make it very easy for us to use and very easy to understand. And also the EQ provide a dependable effectiveness and very highly accuracy and easy to understand the system operation or functioning when it combines together from the EQ data that we collect to we convert it or we insert it inside our LabVIEW to integrate the operational system, putting it very real close to a real world engineering application and making it very useful and engaging for everyone to use it. It's very dependable, it's very highly accurate, the data, it's very not too hard, not too easy to use, easy to understand how the operation works. And that's the good part of collecting DAQ data and also integrating it with a LabVIEW. It's very important for this for our project, and it's you can use also for other project that need to collect data, that need to use a very precise application to collect data. So you can use DAQ and you can use LabVIEW also to integrate the data and to optimize to make your system more accurate, more easy to understand. The flow is very easy. Okay, so that's all from us. That's all for this week video. Thank you so much, guys.